Hey guys. So you were assigned question number 2, and question number 2 is about this mysterious planet, and we have to go through and try to figure out a couple different things. We've got to find the angular speed. Angular speed is omega. We've got to find the centripetal acceleration, and we've got to find the tangential velocity, lots of things to find, and the path length of the planet. Okay, so to find these things, I have to use some information. I know that it orbits its star, so that's a revolution, 30 times every Earth year, or 32 times. So there are 32 revolutions per year. I know that there are 2 pi radians per revolution. 1 year has 365 days. And I gotta try to get this in meters per second because that's the units, just to remind you. Sorry, radians per second. 365 days. 1 day has 24 hours, and 1 hour has 3,600 seconds. So all of that gives me my omega, and I got to do 32 times 2 pi. Everything above the top is just 32, so that's going to be 64 pi over 365 times 24 times 3,600. It's a really big number. 31536,000 seconds. It's radians per second because revolutions canceled with revolutions. Year, year, day, day, hour, hour. All right, and that number, I'm going to get a decimal. 64 pi over 31536,000 is an omega of 6.37 times 10 to the negative 6th radians per second. Okay, I need to find, so that one's done. I need to find centripetal acceleration, which is meters per second squared. Just sort of putting units to remind myself. Meters per second, and path length will have units of meters. Okay. Doesn't really matter which one we want to do next. I'm going to pick VT, just because it's in my mind that the tangential velocity is equal to omega times r. Well, r is given in 12 million miles. So I got to change that because I don't like miles. So I'm going to do another conversion. 12 million, which is that many miles. And I know that, just off the top of my head, there are 1,609 meters per 1 mile. So miles cancel, which gives me 3 times 1,609, 1.93 times 10 to the 10th. To the 10th meters. Okay. So to find VT, it's just as simple as plugging in my 6.37 times 10 to the negative 6th, times my radius, 1.93 times 10 to the 10th, got to be in the right units, which is big number, 122,000. 991.96 meters per second. This planet is hauling, going very fast. But you got to think about it. It's closer into its planet than ours is. We have 93 million miles, and it's circling it 32 times every year that we do. So it's got to be going pretty fast. So that's pretty cool. Tangential velocity is all set. Centripetal acceleration is found a couple different ways. Doesn't really matter which one we do. I'm going to do, you can find it either through omega squared times r or vt squared over r. Again, doesn't matter which one you pick. Just for the sake that I drew this one first, I'm going to do omega squared times r. So my omega is 6.37 times 10 to the negative 6th. I want to square that. And then multiply by my 1.93 times 10 to the 10th. 6.37 times 10 to the negative 6th squared. Make sure I have parentheses in the right spots. Times 1.93 times 10 to the 10th. And I get a centripetal acceleration of 0.78 meters per second squared. Okay, so centripetal acceleration is done. And the last thing I need to find is my path length. And if you remember, path length is r times theta. What we're doing, we want to find the path length through one revolution. And one revolution is equal to 2 pi radians. So all I need to do is multiply my radius. I lost it on here. 1.93 times 10 to the 10th meters times 2 pi. It's going to give me my path length. Basically, this is the circumference of the planet. Because I have the radius times 2 pi. 2 pi r is the radius. Which is, not the radius, the circumference. So that's 1.93 times 10 to the 10th times 2 pi. And I get a big, huge distance of 1.21 times 10 to the 11th meters, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just to show you how many zeros there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 121 billion meters. Pretty cool. It travels in 1 year. Oops. Alright, that's a little extra. You didn't have to do that. You could stop right here, but just show you. So, this type of problem, the key thing is really just a lot of conversions and a lot of plugging in and trying the different equations and making sure we have the right units. Omega has radians per second, centripetal acceleration, meters per second squared, tangential velocity, meters per second, and S, remind you, is path length, which has units because it's the length of meters. All right, hopefully that helps, and you'll have a similar problem tomorrow to work on in class, and then we'll all get into our groups 1 through 4. Have a good day, and see you tomorrow.